Welcome everyone to Tipping Points episode 29, where we ask key questions about how we balance conservation and development. This webinar series is an initiative of Oppenheimer Generations Research and Conservation, and webinars usually take place on the last Thursday of the month at 1 p.m. I'm Professor Lindsey Gillson, Director of the Leverhulme Centre for Anthropocene Biodiversity at the University of York, and I'm also Emeritus Professor at the University of Cape Town. I'm interested in ecological change and how we can blend knowledge from the past into understanding how we shape the present and future. The focus of today's webinar is on how palaeoecology, the study of past ecosystems and environmental change, can help us to navigate the complex and changing world we find ourselves in. And our speakers will tell you about their research, which works with lake sediments and different proxies, such as fossil pollen, charcoal, and isotopes. They're going to demonstrate how this sort of knowledge can inform conservation and sustainability in the future. We're really pleased to be here with you and look forward to a productive and insightful discussion. Just be aware that the session is being recorded. It'll be available on the Oppenheimer Generations Research and Conservation YouTube channel, and you can also catch up there with any webinars that you've missed. I encourage you to sign up for the newsletter, OGRC newsletter, and also stay tuned to OGRC's social media channels. We're excited to have such a good turnout today. Thank you for coming. Please continue using the chat box to introduce yourself, and also for any questions that you have throughout the webinar, and we'll move on to those at the end. So today I'm very pleased to introduce and welcome our panel of experts who are all using palaeoecology to guide and inform the management of ecosystems today and in the future. Our first speaker will be Dr. Estelle Razanat-Soa, who will talk about her work in Madagascar, which blends ecological, cultural, and scientific knowledge. Estelle's a junior research fellow at the University of Cape Town and is interested in integrating palaeoecological data with modelling and other techniques to inform climate change adaptation and conservation in the changing environment. After that, we have Professor Kay Zhang, who will tell us about how he's using the reconstructions of the long-term dynamics of lakes to help address the challenges of sustainability and ecosystem services. Kay is a professor at the Nanjing Institute of Geography and Limnology at the Chinese Academy of Sciences, and his research focuses on how palaeoecology can help the sustainable management of freshwater ecosystems. And then our last speaker is Professor Jemma Finch, who will talk about the management options for two coastal lakes in South Africa that are facing very different futures. Jemma is Associate Professor in Geography at the University of KwaZulu-Natal, and she's a paleoecologist interested in past climate and environmental change. Her research integrates many disciplines to provide perspectives on today's environmental challenges. And the whole team here today are part of a working group, PAGES, Past Global Changes Working Group, looking at how paleoecology can help inform planetary boundaries and safe operating spaces. So I'll hand over to our first speaker, Dr. Estelle Razanat-Soa. Over to you, Estelle.
Thank you so much, Lindsay, for the great introduction, and thank you everyone for coming to this session. So my talk today is going to be looking at how we can explore palaeoecological data to inform policy. And so I don't think I need to talk much about changing environment or climate change anymore, but we all understand that, and we are all thinking about like sustainability, how we can conserve, how we can manage our biodiversity and sustainably use them to ensure that there is benefits for our future generations. However, the majority of conservation approaches that are existing today is based on current ecological data. And what I mean by current is data sets that have been collected over the last 20, 30, 40, or 50 years. However, we need to think about those grappling between biodiversity conservation and climate change mitigation. And this is, in those cases, it's necessary to have more longer-term data that spans on a century or millennial timescale, where we could be able to detect changes in the response of vegetation, for example, to shifting climate and land use. And so it's where palaeoecology comes in, where we look at different proxies, which Lindsey mentioned, from lake sediments. From that lake sediments, we look at different proxies and have records from the past going up to the present period. And so from that perspectives, I will bring you to Madagascar, where I grew up. And if you haven't been to Madagascar and you hear the words Madagascar, you think about tropical forest, you think about jungle. I thought about that as well before going into palaeoecology, because this is what they taught us at school, with the assumption that Madagascar has been fully covered by forest before human arrival and human settlements. And when we arrived as people being there, we started like using the land and cutting those forests. However, when you look at the landscape in Madagascar nowadays, you have this, which is a diverse ecosystems. For example, in the northwest, you can see palm savanna, you can see grasslands, you can see dry deciduous forest, and of course, tropical forest, as you would expect it. So we looked into the palaeoecological data that we have from the different sites I put in red in here. And the results that we got is like this. So the red, the pinkish is the grass, which shows how open ecosystems or grassy ecosystems are abundant within the area. And the blue is the tree. So when you look at those four graphs that I'm showing, there is an abundance in grass, as you can see. And this is starting from 6,000 up to the present period. Human was supposed to have settled in Madagascar around 2,000 years ago. Number two that you can see here as well is that there is a massive increase in grass, around 1,000 for all of those. So there are different theories and debates about what causes them. But one thing that is common is that this grass component has been maintained by human activities through fire in the last 1,000 years, in addition to climate. So those are an indicator of how the landscape has shifted, showed us the presence of open and mosaic landscape in the past. And this open vegetation that we see today has probably led to a shift in the processes as well, which could help us in terms of management. And so we took those results, we bring them to with a stakeholder engagement that we hold in 2022 and 2024 in Madagascar, where there were people from the government, ministry, people from academia, and also people working, NGOs working in conservation in Madagascar. We discussed about the importance of those on how to acknowledge those open ecosystems within restoration and reforestation approaches. For example, in thinking about what were the appropriate species that could be used within those areas. We discussed also about fire management, because if we know where and how those open landscape has been there, if those open landscape has been there before humans, that would mean there needs to be adapted management related to fire use or fire presence in the past. And all of those can be done with the work with local communities. And so palaeoecology, or a long-term data set, has been complementary with existing approach that are conducted presently. And so this will result in a policy briefs that we are aiming to be integrated as part of the national biodiversity action plans in Madagascar in the next few months. And this has brought also light into all the participants on how paleoecology can be used and how the landscape in Madagascar has been, and not the forested jungle island that we thought it was. And so based on that, I hope I showed in the last 7 minutes how paleoecology have changed that perception in terms of trend and pattern, showed the relationship between human and environment. You will hear more from Kay and Jemma later on. But what needs to be done is for future work is for us to identify and differentiate those anthropogenic and ancient open landscape. And this is where we're using dynamic vegetation model. And on that note, I'm finishing my talk there. Thank you.
Thank you so much, Estelle. That's really interesting work emerging from Madagascar. As I said, we're not going to take questions right now. We will at the end. So I'm going to hand straight over to Kay.
So thanks, Lindsey. And hello, everyone. Good to be here. And today I'm going to talk about how we try to use the lake sediment, try to understand kind of how the lake change and how they involved with the catchment, with the society. And we know the global lakes facing the kind of common challenging in the Anthropocene, and currently I involve a international project, work with Lindsey and Jemma in the team, and we try to compare the lakes in Africa, South Africa, and in China. We try to use 3 lakes to understand how the lake ecosystem have been changed, and how they use the lake sediment as a way to try to inform the management. And apart from this, I also involved in another project working in other part of Africa. And this photo actually is we taken in February last month. We went to the Great Rift Valley. There are lots of lakes, and like Lake Naivasha or Baringo. And we talk with managers and people around living there, and we get a sense that the lakes in Africa, and lots of lakes, and they're facing the similar kind of climate warming, caused the water level change, and also the biodiversity loss, and also the eutrophication, like algae blooming, because of catchment intensification. So maybe it's a little bit, it's not that kind of intensified, but compared with China, but we think in the long run, maybe in the next 10 years, 20 years, probably it will go to the similar direction. So compare with the lakes in China and Africa, and I think could generate a very interesting, maybe useful perspective. So this talk, I will show how we use the lake sediment working in China in one of the Taihu Lake as example how we do this kind of studies. Taihu Lake is kind of symbol of Chinese development model, and it's in the eastern part of China. We can see that, and this is Shanghai, so very close to Shanghai over the last several decades. It had been the super fast development in big cities and population. We can see the urban areas grow very quickly, but also causing serious kind of water issue problems like algae blooming. So the government had tried to fix this problem. They spent around 100 million RMB, equivalent to $15 billion in just 10 years, but still there's lots of problems. So gradually we realize that it's the lake is a kind of complex system. It's not only about the ecological, but also people on the catchment. So we should understand the behavior of the lake from the long-term kind of perspective, how they evolved from the past to present. That's where the lake sediment have been kind of came from. We use the lake sediment to get long-term data and use that information, try to kind of inform the lake restoration and management. So this is the Taihu Lake. We can see still with some algae blooming in the summer seasons. And based on that, we develop an evolutionary framework. We combine with the lake sediment with a long-term biophysical record and also with historical information. We try to understand the past, present, future continuum, how the lake socio-ecological system have been involved, and we can identify the tipping point, the regime shift, and the variability of change. Then we know what kind of stage the current lake in. And this is our data. We can see from the figure, we can see the thick green line actually is it's generated by the lake sediment. It's lots of proxies, like soil erosion with the DNA and also lake productivity, pollution. So this all the proxy are generated by the lake sediment, and this is represents the speed of the ecosystem change. That means is how quickly the ecosystem have been involved at 100 years kind of perspective. And the purple line is kind of a social economic speed. And we try to compare with the two different components of the system, how fast the socio-economic development and how fast the environment degradation. Actually, our data show that pre-2000, the rate of environment degradation is closely paralleled with the socio-economic development. That means it's a highly coupled system. So environmental development at the whole cost of the environment, social development. But after the 2000, our long-term perspective data show that the economic growth have diverged from the ecological decline. That means there's a decoupling between the linked ecosystem. And understanding this kind of perspective of transition is important because we spend a lot of money intervention if the lake is in the coupling phase. So that means the environmental degradation very fast follow the economic development. Even you give lots of investment, input, effort, actually it's not easy. It's still you can't see very big progress. But if the lake has been transitioned, so the intervention effort are likely to become more effective. So this kind of information is crucial from the long-term perspective to know where we are for the lake socio-ecological system. And based on this, our paper published last year on the PNAS, and we based on this paper read some kind of policy kind of advisory report to emphasize the long-term evolution of the system. And actually this kind of report had been adapted by the Chinese Academy of Science and also Department of Environment of the Jiangsu province, that they really kind of interested in this long-term perspective to know the system, and based on this to make some kind of policy or kind of restoration strategies. And based on this, and because we have long-term kind of biodiversity or water quality pollution data, and also we try to develop a kind of safe operating spaces. For example, we know the tipping point or boundaries of the different component of system, like the biodiversity loss or the eutrophication, which part of the system has crossed a boundary. And this is useful for the managers because they can easily understand which part of the lake is being seriously damaged and which part is still okay, so they can make a more kind of systematic perspective to manage the lakes. So based on this, actually, we develop an online platform. So if we have a kind of long-term data for any other lakes, you just put your data in the system, you can show the long-term trend, and also you can compare with the different year of the lake, how the lake had been, which part of the lake system has been crossed the boundary, which is still in a very good state. So combining with kind of current monitor data, so it's easily for the manager to understand the lake and take proper action for the lake kind of management. And that's my talk. Thank you very much.
Thank you so much, Kate. It's great to see the work being translated into policy and action. It's really nice to see. Okay, our final speaker is Jemma Finch. Over to you, Jemma.
Hi, everyone. Thanks so much for joining today. So I'm going to be looking at how we can apply this paleoecological data to help inform ecosystem management in the South African context. So as a paleoecologist, I'm never happier than when I'm out in the field, very muddy, collecting sediments, and even happier when I'm looking down the microscope and counting my microfossils, getting excited about what I'm finding, and producing these very intricate looking stratigraphic diagrams that you see in the center of the slide. But really, at the end of the day, despite the fact this might make me very happy, we need to find ways of making these data sets more accessible to practitioners, managers, and so on. And really, that's the point of this webinar and the point of the research that we're undertaking at the moment, to try and make this work more easily understandable by those who are actually managing these ecosystems. So for the purpose of this talk, I'm going to focus on 2 case studies: coastal lake systems in the Cape. Princess Flay is in the Western Cape, and the sediment record covers 2,600 years. Eland Flay is in the Southern Cape Coast, part of the Wilderness Lake Complex, and covers the last 9,000 years, so a much longer record. And we're going to be using existing data sets generated by Kelly Kirsten and colleagues. Kelly is now based at Coventry University and is sitting on the call. So Kelly is a diatomist and uses diatoms as a really useful indicator of past water conditions, water chemistry, and so on. So diatoms are unicellular algae which produce these beautiful siliceous microfossils, which you can see in the center of the slide. Really, really intricate morphologies which you can use to identify which taxon we're looking at and infer something about the water conditions. So let's look at what these records show. If we start with Princess Flay, you can see this 2,500 year record here on the x-axis. So this is 2,500 years ago, moving forwards in time to the present day, which is now 0. And essentially what this graph is showing is a shift in diatom community composition. And specifically, this summary focuses on diatoms that are adapted to high nutrient conditions, shown in blue, and those that are adapted to low nutrient conditions, shown in orange. And what should immediately pop out to you when looking at this summary graph is that we've got a very marked changeover in the diatom community shown in this record, which is quite fascinating for us as paleoecologists, looking at something that is suggesting different stable states in the ecological community. So we move from a relatively high nutrient phase in the early part of the record to a low nutrient phase, the central part of the record. And then in the very recent past, particularly since the timing of European colonization about 300 years ago, we actually have sort of a human overprinting of this environmental signal. So land use activities become more important in driving change in this record. But what we are particularly interested in for the purposes of this project is these shiftovers or transitions in the community structure, which are shown here in gray, what we might term tipping points or critical thresholds where we see the ecosystem transitioning from one regime into a very different regime. So that is specifically what we're focused on here. If we look at Eland Flay, which is in the Southern Cape, part of the Wilderness Lake Complex, here we've got a much longer 9,000 year record. And hats off to Kelly, because as much as we get excited about mud, when Kelly and her German colleagues and others from UCT went out to go and core at Eland Flay, expecting to get a couple of meters of sediment, that core kept going down for 30 meters, which is the equivalent of a 10-story building. And somebody's got to analyze all those sediments. So well done, Kelly, for sticking it out. Nevertheless, she produced this magnificent record. And we can see here at Eland Flay that what's interesting is not the nutrient status that's indicated by the diatom community, but rather the degree of marine or freshwater influence. So in this case, the orange line represents diatoms that are adapted to marine conditions, whereas the blue line represents those that are adapted to more freshwater or dilute conditions. So again, you've got this rapid changeover from one system state into another, except in this case, with the wilderness system being linked to the ocean, it's marine influence or sea level that is causing this change. So we've got a highly marine phase at the beginning of the record and also in the central part of the record, coinciding with the Holocene high stand where sea levels were higher than the present day. And then we've got a freshwater phase in the more recent part of the record. So these really marked changeovers with these tipping points that we are really interested in. So the aim of our project is to take these existing records and now model them using approaches similar to what Kay has illustrated for Tahoe Lake. So this modeling then, we can start to look at things like range of variability in the past. So taking these longer term records and seeing how much the ecosystem has changed through time, the rates of change, how quickly is the system changing? We can look at different variables to analyze this. Then for the sake of this webinar, we're really interested in tipping points, also what causes these tipping points. So actually modeling these long-term records to identify those critical thresholds and then try to figure out what is causing those changes. And then importantly, to take these model outputs through to our stakeholders, ecosystem managers, conservation practitioners, and so on, as was illustrated so nicely in Estelle's talk. Through these stakeholder engagement workshops, we can really start to ask the managers on the ground about different potential future scenarios and really take the work to the next level by engaging with those who know what are the right questions to be asking about these ecosystems because they're working on the ground. And then just to finish off, not to lose sight of a broader scale perspective, these long-term data sets are also really important for helping us to define safe operating spaces. So within the planetary boundaries framework that Lindsey and Kay mentioned, how can we use an understanding of natural variability throughout the Holocene, so relatively stable, favorable conditions to inform and define limits to different Earth system processes on a broader regional to global scale. Thank you, everybody.
Thank you so much, Jemma. That's a really fascinating data sets, and as you say, a really impressive piece of work by Kelly there. So do keep your questions coming in the chat, but we will start with a few that were submitted by via Eventbrite. One is about the application of this work. So we heard from Kay that governments are using the data from lake systems, but is that happening in South Africa and Madagascar as well, Jemma and Estelle?
So I will start. I think, so in Madagascar, there hasn't been really work on paleoecology long-term data inclusion in any of the conservation approach that's happening today. But what is starting is that people are starting to recognize it, and the workshop is like one step towards that, building onto the policy report. But one thing that is already kind of like ongoing is acknowledging the different species composition that can be used in terms of reforestation. And so like, instead of having working with invasive species or fast growing trees, not endemic, then people would go more into native. So I think that's one of how paleoecology has already started to contribute to that, in addition to ecological knowledge in the case of Madagascar. And then for South Africa, I will pass to Jemma.
Thanks, Estelle. So I think in the South African context, this is really something that we are still working towards, certainly on a broader scale. There have been a lot of small scale studies, particularly by Lindsey's group at UCT, which have shown quite close interactions and engagements with conservation managers. And you know, I think that's really important and something that we all need to take a leaf out of your book and interact more closely with managers on the ground. So, I mean, there's some nice examples, but one that springs to mind is Cherie Dirk's work at Elandsberg Private Nature Reserve. So again, relatively small scale. This is a small reserve in the Berg catchment on the west coast of South Africa. But I know Cherie worked really closely with local land managers and chatted with people at Cape Nature. There were a lot of interviews and workshops that took place. And ultimately, she was able to use her paleo data sets together with a modeling approach to produce a decision support system. And I was actually having a look at the tool that she generated online, which is still available to take a look at, and I'll post it in the chat just now. But I think really that's the type of thing we need to be working towards. And I hope that with this project, our NRF-funded project with Kay and Lindsey and others, this is something that will become quite an important focus of our work, and there are workshops planned to really take these model outputs and chat with the managers on the ground.
Thanks very much for that. It's sort of very much, we feel underutilized at the moment, but with great potential. Okay, so then another question has come in about tipping points. So we saw in the data that we can see past tipping points, but the future could be different. So could you just say a bit more, any of the panel, say a bit more about how we know these things will be relevant in the future tipping points?
Can you say that again, Lindsey?
How do we know that our knowledge of past tipping points is going to be relevant in the future?
Yeah, from our research experience, we know that because the tipping point normally is unpredictable, and if it happens, it's very quickly, and sometimes it's irreversible. So the reason we understand the past tipping point, actually, we want to predict in the future, because it's really happening in the past, but we don't have any data. But the paleo data recorded all this kind of thing. So during understanding the process of the tipping point, we can actually using their mechanism like early warning signals from the lake sediment, and actually we can at a certain level to predict, or maybe not a tipping point, maybe a tipping point zone kind of thing, kind of to enhance our kind of predictability. And also the tipping point thing is more, I think, is about linear change. Because lots of environment conservation or management, they take a linear thing. They think we increase the driver, the environment degradation. If we reduce the driver, the environment will recover. Actually, the tipping point says that sometimes it's kind of non-linear change. And that will be really incorporated in the future, I mean, for the management or modeling things, because sometimes it can happen not only the climate tipping point, for the lakes, for the ecosystem, for the forest, they all can maybe collapse suddenly. So I think that's one of the reasons from my perspective.
Thanks, Kay. I think that applies across the board, doesn't it? If we can understand where thresholds are in systems, we're more likely to be able to anticipate them. So I'll move on now, if I may, to the questions that are coming in from the audience. And Fred has asked, what motivated all of you what brought you to the topic of paleoecology? So we'll just go around the group. I'll start with as we'll go in the audience vote. So I'll start with Estelle, then Kay, and then Jemma. If you could just say a little bit about why you became paleoecologists. Thanks.
Yeah, I mean, I think for me personally, it was the fact of blaming people. So like we had from early on, I always knew about like Madagascar, biodiversity, and all of those. But then on a level, as someone living in Madagascar, you always hear the fact like, oh, we humans destroy our biodiversity, cutting all the trees and all of those. And so it's kind of like was this really what we had in terms of vegetation? Did we really cut them in 1,000 years? Did we just like clear everything to make it open? So I would say that is like trying to understand what is humans' contribution to the change in the biodiversity in order to be able to participate in that conservation in itself, but also to say to people that not everything has been bad and we're not that bad after all. We can still do something about it, I would say.
Thank you so much, Estelle. I think that's a wonderful motivation. And Kay, how about you? What brought you to paleoecology?
Yeah, it's a good question because I think from my perspective, we maybe yeah, because it's we know that lots of kind of environment problem is very complex. It's kind of it's not kind of they call it a wicked problem. So lots of environment issues we want to solve actually have some side effect. So if we don't understand from a system perspective, it's very challenging to solve a real issue. But if we want to understand the system perspective, you need long-term data. And because the system is evolving, if you only have 1 year, 2 year data, you can't understand the behavior of the system. Like a people, if you go to the doctor will ask you, like in the Chinese medicine, they will ask you what you do in the past, maybe 2 years, 3 years, even 10 years. So similar. So we need this kind of long-term perspective to understand, to solve the social ecological issues if we really want to find this kind of solution. I think that's a part of way. Yeah, I'm really interested in this kind of complex system perspective, and also using the long-term way to try to understand this kind of change. Thank you.
Thank you, Kay. And you, Jemma, you've already showed us your enthusiasm for fieldwork and microscopy. So yeah, can you tell us a bit more?
I have a few different answers, but I think the first one is I've always loved the idea of exploring different environments, especially wilderness areas and being in the outdoors. So I love being in the field. And I think the idea that you can take something like a sediment core and travel back in time to, some point in the past, which is hard to conceptualize, 10,000 years ago, 20,000 years ago, we're in the middle of an ice age. It blows my mind. I love that idea that we can go back and produce these fantastic records. And then just the application of them, they're so versatile. So I'm fascinated in the ecological aspects and asking questions around ecological processes and function. But equally, in the context of climate change, to understand different climate drivers, there's just so much we can do with these records. I think they're incredibly powerful and underutilized. So I hope that this project will help to really make our data more relevant and more useful to be available where needed.
I think that's a great observation, and we'll all try and work towards that goal of making our work applicable. Just quickly from my side, I was interested in elephant management and whether there were too many elephants and whether they were destroying their habitat. And I kind of realized we don't know what their habitat kind of should look like, because we don't know what it looked like prior to international ivory trading, for example. So we needed to look back in time. So that started me off on a whole journey of questions where we needed to understand systems over long time periods. Okay, I'll move on to the next question, which is for Kay, from Elliot in Coventry. And Elliot's interested in how does your work, how can it be applied when the thresholds have already been exceeded? So he mentions Lake Texcoco, excuse my pronunciation, as an example. And then, so what conceivable methods exist to bring them back within range, or is it indeed just not possible?
Thanks. It's a really excellent question. Actually, we also think about that because I think this different perspective. First is we know we call the kind of environment ceiling because it's have a kind of threshold or tipping point related. Once you crossed, it's not easy to reverse because they have a kind of hysteresis or time lag kind of thing. And I think from my perspective, you define the ceiling in the short or mid-term perspective, maybe it's really challenging to kind of to bring the within the range of ceiling, but at least you can prevent, because they have a different kind of tipping point. You can prevent a future kind of even go to shift to a more degraded state. Like the lakes, we have eutrophication, we have algae blooming, but if the algae blooming carry on intensified, they will develop to the hypoxia and very serious, even the dead lake they called. So I think one thing to define the ceiling is to prevent the first thing is to prevent the future kind of the lake go to tip to another even more serious state. And in terms of how to bring the lake back to the environment variability, like lots of lakes in China, actually they like Taihu, they spend lots of money, they use lots of technology, engineering things. Actually, it's not kind of easy. And in this circumstance, and we saw it's the purpose maybe not just to kind of restore to the pristine lakes, but actually to develop a strategy to mitigate the potential risk, like if there's a head wave or kind of climate extreme event will cause the lake to have a really big disaster like the drinking water crisis. So you need to have that kind of adaptive solution for the lake already cross the threshold, and how to tackling with this kind of crisis. If that happened, I think you need to make more kind of options. And at the same time, from a long-term perspective, you can use a different, like they said, the nature-based solution, but it will not happen in 1 or 2 years. It needs a long-term perspective. I think you need different kind of strategies to prevent the disaster, and also kind of use currently we say that the nature-based solution to have a long-term kind of restoration goal. It's not you say that we can't fix it in 2 or 3 years or 1 year. Sometimes that's why the paleo record from the lake sediment side is not really can happen. Thank you.
Okay, thank you, Kay. And sometimes we just have to accept that we're going to have to adapt to novel conditions. There's really interesting paleo work from Australia by our colleague Peter Gell showing that some systems, they're going to provide a different suite of ecosystem services. So we have to sort of accept that possibility in some cases. The next question is about early warning systems. So are there any signs in paleoecological records that we can use to show that a tipping point is imminent? Does anyone want to take that one?
Yeah, I think some of the signals that could help us identify a tipping point would be a change in the species composition, like there would be some extinction of certain species, and also the presence or extinction of invasive species, and that could already inform us of a shift towards a new system.
Yeah, so we have seen this phenomenon of flickering, haven't we, where you get greater variability before a tipping point. The next question is from Finbar, who's asking about paleoclimatic records from Lake Chad and how paleo records could help with cycles of shrinkage and recovery. Has anyone worked on Lake Chad, or is that a bit outside of our field?
I'm not familiar with the paleo records from Lake Chad specifically, but just as a general response, if we do have these types of paleoenvironmental archives available that tell us about perhaps changing lake levels, so diatoms would be good for that, for example, and other geochemical indicators, we can take a longer term record and start to analyze what is the range of variability throughout the length of the record, and actually see, how much has that lake level fluctuated through time. We can, one of the most powerful things I think about paleoecological work is that we can tie it together with other proxies or indicators. So by using independent climate indicators, for example, and then comparing with what something like lake level or lake water community composition is doing, we can start to ask questions about what is causing those changes. Is it being driven by rainfall variability, for example? So yeah, it's a generic answer, but essentially that is what we would do to understand these types of long-term patterns.
Thank you, Jemma. The next question is from Tamrin, who's asking, should we expect to find more frequent or extreme shifts in lakes that are more human influenced? And Tamrin's actually asking two things as well, because she's saying, are human dominated systems less resilient? So first part, should we expect more frequent and extreme shifts? And secondly, are human-dominated systems less resilient?
Yeah, and I think it's a very good question. And from if we take an example from lakes in China and the lakes in Africa, because we went to the Great Rift Valley last month, I mentioned we see lots of lakes there, and we talk lots of managers and peoples there, and from their perspective, they saw that the lake is really very serious because the water level change, and also they have a eutrophication, even some algae blooming in part of the lake. And but from our understanding, actually, it's not that kind of serious, but because it can get even worse. So what I want to try to say that yes, the human dominant system can be more easily to degrade, more easily kind of extreme shift happened. But on the other perspective, like a Taihu Lake, the government really put lots of effort. They want to do the green transition, so they use all the technology, the resources, try to restore the lakes in the nature-based solution of engineering things, lots of resources. Actually, they gradually try to make the lake is more resilient. That means, you know what I mean? So the human can damage the lakes, and it can have an extreme shift very frequently. But on the other level, if human using their kind of technology, new resources, actually they can make the lake more resilient. I think it's from two spectrums. So one part is really serious. The human dominant system, if they don't care the environment, will be more easily shift. But the other part, if you really want to look care of the lakes, it can make the lake more resilient and maybe less chance of a shift happened. Yeah.
Thank you very much, Kate. One last question, which is about modelling. And as I happen to know that Jemma's project is a very early stage, I'm actually going to give this one to Estelle. So perhaps you can talk a bit more about the interface between paleoecology and modelling and how that helps us to manage the future. Thanks.
Yeah, thank you, Lindsay. So what the model that I'm working on is a dynamic vegetation model. So basically, we have the palaeoecological records, which is from a specific site. But for managers or stakeholders, they need to have a more broader spatial understanding of how the landscape has been. And so using those models, we're able to simulate, like, this is the extent of, for example, the grasslands within a certain area in the surrounding of the pollen records. and then we compare them and see then, and that outputs can then be used by stakeholders in thinking about where we can do reforestation and and so identify the appropriate place for reforestation project, basically, if that responds to your question.
I think that was really helpful. Thanks, Estelle. So I think that's all the questions we've got time for. I want to thank all the speakers for your fascinating talks and the audience for your questions and for listening. And then I just want to flag the next OGRC Tipping Points webinar, which is scheduled for 24th of April, where we'll be having a discussion about the effects of the US funding being cancelled and how that will affect African research and projects. So keep an eye on the OGRC social pages for that. And you can sign up to their newsletter as well. There should be a link in the chat box to sign up for that newsletter. And if you missed any part of the webinar or you want to revisit it or see any of the others, there is an OGRC YouTube channel, and a summary of this webinar will be available on the OGRC website. So once again, thank you all for participating, and we look forward to seeing you again on the 24th of April, where we'll be focusing on that important issue of how US funding cuts are going to affect African research. Okay, thank you very much, everyone.